Problem number 1. I have two different samples, Group A, Group B. I have yeses and nos, and I've given the totals. Now what I'm trying to do is see if Group A could possibly be the same as Group B, or whether perhaps they're different. As a matter of fact, let's go even further. Let's make this a one-tail test. Suppose that I believe that in general Group A has a lower proportion than Group B. For the null and alternative hypothesis, the tendency is, instead of to talk about A and B or women and men or whatever the two groups are, you just use 1 and 2. But now we have to make a connection between these numbers and these categories. So I'm just going to put a 1 above the A, a 2 above the B, so I know that Group 1 and Group A are the same. If I suspect that Group A has a lower proportion than Group B, then, as before, that becomes the inequality that I use in my alternative hypothesis. I've given it in terms of yes, no, and total. The calculator is going to want x and n. Now x, those typically are the yes scores, so that would be 108 and 136. N, those would be the total respondents, so 323 and 334. P hat, I'll have to wait for, it should be part of the report that I get. I'm ready for the calculator now. I'm going to go stat, tests, and this is going to be a 2 proportion z-test. Proportion because they're yes-no type questions. 2 because I've got 2 different samples, and I'm running the test right now. So, line 6, the 2 prop z-test. X1 is 108. N1 is 323. X2 is 136. N2 is 334. The inequality that I used was a less than, and I will calculate. Now, I get a lot of information. Z is negative 1.931. That's my test statistic. I'll make a note of it. P, well, there are lots of P's here. There's P1, P2, P hat, and P hat for both groups 1 and 2. This P, the first one, is actually the probability of getting an event like that or something more extreme by chance. So this is going to be 0.027. I like 3 decimal places, at least 2 significant figures. That is less than 0.05, so I will reject the null hypothesis. I'm not quite done. I want to fill out the rest of the summary statistics information. Do you see how there's a P1 hat? That would be 0.334. There's a P2 hat, that's going to be 0.407. So, about 33% of Group A said yes, about 41% of Group B said yes, and I have enough information to say that the two groups are different. There's a natural follow-up question. to problems like this. Once I accept that Group A and Group B are different, the natural question is, how different are they? Now, you only do this if you reject the null hypothesis. But if you reject the null hypothesis, the follow-up question will be done with a 2-prob z int, and it ends up being very simple to do. Stat tests. 2-prob z int is very far down the list. I have it on line B. I will run a 2-prob z interval. And do you see the numbers? Those are the same values that you just plugged in. I need an appropriate alpha level. And this is where things get a little bit strange and where you have to understand the picture. Generic bell curve, centered, and I'm going to be measuring z's. Now, the center is going to be where P1 equals P2. I'm going to write that as P1 minus P2 equals 0. I'm interested in only the less than side. So I'm only going to reject if I get a negative z-score. Now, that means that instead of taking the 0.05 and splitting it up so that half was on one side and half was on the other, I put the entire 0.05 on this side. There's a critical z-score. The simplest way to find it is to go inv norm 0.05. It will be negative because it's to the left and 1.645. It's a value that shows up frequently. The negative 1.931 was somewhere out here. Now we would fail to reject if it was somewhere in the shaded region. I'll mark that as FTR. We would reject the null hypothesis only if it was somewhere out in the left tail. Now suppose we want a confidence interval that has this same value. Remember that confidence intervals are symmetric about the center. So if we leave off 0.05 to the left, we'll also leave off 0.05 to the right for symmetry. So it's only going to be a 90% confidence interval that I'm looking at. The rule is, if it is a two-tail test, then the confidence interval is 1 minus alpha. If it's a one-tail test, then the confidence interval that you're going to use is going to be 1 minus 2 alpha. Sometimes I like to say that one of these gets doubled. Either the tails are doubled or the confidence interval, the alpha, is doubled to get that second tail in there. So, I've entered everything in. I do have a confidence level of 0.90, so I'm ready to calculate. The confidence interval is from negative 0.135 to negative 0.011. But I like a plain English statement. So, here are going to be the elements. First, bought burrs, based on these being representative samples, I am a certain percent, 90%, because that's my confidence interval, certain that the proportion for group A is blank, then the proportion for group B by between blank and blank blanks. I just want to explain what goes into these blanks. I don't like putting negatives into plain English statements. So here I've got 0.135. I'd like to get rid of the negative. I'd like to turn it into a percent. So this is really on the order of 13.5%. This is of the order 1.1%. Now I'll go from the lower value to the upper value. So the 1.1%, the 13.5%, those are the magnitudes. You'll notice that I got rid of the negatives. That's because negatives just confuse people when you use English. The better way around it is up here to use either lower or higher. So the proportion for group A is lower than the proportion for group B, and that's what the negative is all about. P1 minus P2. We ended up in the negative territory because P1 was less than P2. Units of measurement. I like saying percentage points. So, my plain English statement, based on these being representative samples, I am 90% certain that the proportion for group A is lower than the proportion for group B by between 1.1% and 13.5. Oh, my apologies. Percentage is listed by between 1.1 and 13.5 percentage points. So you do the test to decide if you reject. If you reject, then you have to run the confidence interval. You have to decide whether to double alpha and then subtract it from 1 or leave it alone. The 2prop z int is simple to run. The numbers are already waiting in your calculator. The plain English statement is the last part of it, and my name.